Well, well, well. Welcome back. As you already know, if you're a returning customer, basically we just wait in the first 10 minutes for people to come in and then we're gonna start. Hello, Utkarsh. We're just waiting for people to come in and then we're gonna start. We're basically doing a spider robot, so you're in for a good ride. Yep. Welcome, action. Welcome back, Farid. Let's freaking go. We're gonna finish the thing tonight. I mean, what we plan to do, not the entire thing, but you guys will see what we mean. Alright, so enough eating. I was eating popcorn because why not? And basically, let's recap what happened when I was working on my own for a couple of moments. Basically, here is everything you need to know that I did off stream. Here, we added a horn that would attach to the servo. So this is our servo. If we just hide that, there's a horn here that we're attaching to this servo. If you also hide that, this horn, basically from the inside, it's geared, or it's fitted like the gears of the servo, so it would fit properly, and that would attach to the servo. From the other side, as you can see here, we have a roller bearing. So a shaft will be inserted from this side so that if this moves, this doesn't have any friction to it on the other side. So if we get back everything that we hid, this is how it looks like. So if the servo tries to move this tibia like that, it wouldn't have any friction on this side. We're still going to open up the tibia from this side. I left it because the tibia is going to have a lot of work to it. Oh, let me increase the volume then. Or actually just raise my voice. Let me just sit properly here. Okay, so is this a little bit better? Or like this? Let me know, because that's gonna make a lot of difference. And no, Utkarsh, it's not a job. It's basically a project that I'm working on. Me and my friend Farid here, we're trying to make a Hexapod robot. So let me show you how it should look like in the end. This is not the final thing, but this is kind of well, not at all the final thing, but you'll get what I mean in a bit. If you see my previous videos, basically, you'll see what I mean, how the entire spider should look like. But for now, let me just work on the tibia, and once I finish that, I'll attach it to the rest of the body and you'll see what I mean. So, as I was saying, basically this tibia, we have a lot of work to do with it. We're gonna close it in a little bit so that this gap doesn't happen. And then we're gonna open it from this side so it has a place where this roller bearing can fit in. And after that, we're basically gonna change out this tip part to have it better suited for change. So if we need to change that tip to be metal, to be plastic, to be whatever we want, we can just only remove this tip part. We don't have to remove the entire thing. That's first of all. We're gonna add a limit switch inside here as well, and we're gonna try and figure that out. That's actually today's stream, trying to figure out how to put a limit switch inside here. And then from there on, everything else is kind of easier. It's not easy, but it's easier. And if we have time, the last thing we need to do is to start simulation. We want to simulate if this leg can handle the pressure of the entire body or not. So let's say, for example, our spider is going to be 3 kilograms or 4 kilograms or whatever kind of kilograms that you want to add. We want to know if this leg, worst case scenario, this robot is about to fall, so its entire weight is shifted to only one leg. Is this one leg gonna be able to handle the entire weight of our spider or not? So that's the simulation that we need, because that's the worst case scenario. That's how you simulate stuff, to go for the worst case scenario, and from there on out, everything else should work fine. So that's the end goal of today's stream. If we have time, we're gonna simulate. If not, then just working on the tibia for now is perfect. But simulating is gonna be a key factor here to determine if dimensions that we've worked on so far in the previous streams are they good dimensions or not. So all of that is gonna be worked out throughout the stream, but for now, let's just start. Get it bit by bit. Just keep watching and I'll let you understand everything. And if you still have questions, then I'll explain a bit for you. So for now, let's just go ahead with our tibia. We need to work on this first. So we need this thing. Edit part. Trying to have this here. Sketch. Okay. Not coming from okay. Try on. Am I even able to touch? Yep. Not really. Okay. Let's try something else then. Servo. I want that. Yeah, that one. Want to have it as Earth. Yep, I need that outer end. Earth. I forget things a lot easier now, so let me actually do it a very easy way. I don't know why I'm making this harder on myself. Just go here, edit sketch. Oh, okay. That's not easier at all. Where was it? That bracket. That, yep. Edit sketch. Our dimension. So Copy that. Edit the part. Edit that one. Sketch here. Then that. Part dimensions. Paste one there. Here. Cut. Up. Next. Where is it? Yeah, up to next. There we go. With yeah. Have it. Okay, so okay, so basically we can, instead of this roller bearing coming out, in case it moves too violently, it might come out of its place. So what we wanted is have a cover in here instead of this just popping out of its place. There are two ways we can do this. We can either make a cover for it, so I can just draw another circle, like a bigger circle around it, and we can do it with nails and stuff, so, or nuts and bolts and stuff like that. Or we can just, instead of opening this up entirely, we can keep like a millimeter or 2 millimeters covering the thing. So let's try and do that. So let's just undo that cut that we did. And instead of doing it from this side, we're gonna be doing it from that side. And you're gonna see what's the difference right now. So, edit part. And sketch side here this time. I can just sketch it from the side if I want to. That. Still same dimensions and everything. But this time it's drawn from this side, and this is a 5 millimeter thickness. So if we do it like this, where is it? Sure. Oh, feature, root cut. This is 5 millimeters, so we can cut like 3 millimeters. So let's do 3 meters. And yes. So this is inserted in here like that. That part. So if we hide rest, let me finalize that. Let's hide this. Let's hide this. This is now inserted in here. It cannot go out of the other side, basically, because here, as you can see, it's kind of clipping through it, I believe. Let's mark it. Let's see. Huh. Okay. Might be clipping through it a bit, but that really doesn't matter. That actually in real life this part doesn't matter. So keeping it at 2 millimeters so it doesn't break as well. I don't want to make it 1 millimeter thickness. It's gonna break. Even if it tries to pop out, it will just break the 1 millimeter part and go out anyways. So meters is kind of cool. And let's keep it at that and do everything else this way. So let's actually pop out the other stuff that we hid. Okay. Go. So if we're keeping it at 2 millimeters, now we do not need to make this tibia less in it's so we're gonna keep the tibia as it is. We're gonna go here and actually make these C brackets a little bit wider. So this is clipping through it, as you can see. I want to make this a little bit wider, and we can fix that and make a cover for it, as well as this. So these are the same bracket. So whatever we do in one of them, it will affect the other anyways. So you can just do this. Edit part. We're gonna edit this to, what do we want it to be? Want it to come out as 3 millimeters extra, something like that. Yeah, so we're gonna have it to be 3 millimeters extra. Edit sketch. We're gonna come in here, plus E millimeters out of the sketch. Yeah, that's what we need. Exactly. Nice. Out of that. And from here as well, became fixed. Now we can go into this. Where is it? Edit part. Now we can go into that cut, I believe. Or was it? It was that cut. Okay. So, edit sketch. Instead of having that sketch here, we're gonna delete that. Yep. Affect our well, affect our mates that we did. That's okay. Out of the sketch, I know. Major problem. You're gonna fix. Okay, so want to do that from here. Sketch on that. Sketch a circle. How wide do we want it? It is 2, because that's the radius that we're entering. Finalize that like that. Then let's tell it to this sketch, feature, extrude cut. Going with the same 3 millimeter depth. So let's do that. There we go. What a beauty. What a beauty. See? It's not even clipping. It's not clipping through it. That's the end. That line is the end of our ball bearing, and it's not touching the rest of the thing, so it's not clipping through, so that's great. And if we look from this side, there we go. Nothing is showing, it's completely covered, as well as this one, same thing. It's not clipping through, everything is covered. So yeah, that's great. And if we look at it that way, perfect. Still moving, all mates are still there. Great. Nothing issues. Yeah. So we're gonna rebuild that. I don't know if you guys can see that. So if you look at the femur here, this one, there are 3 or 2 dots, like a red and green dot. It's like a traffic sign, but basically this is telling you that you made some changes. You need to rebuild for everything to work together again. So if you look at the very top here, I don't know if you guys can be able to see that. Yeah, it says rebuild, or just hit Control plus B. Rebuild. So it told us to rebuild. We did it. Now the thing beside the femur is gone. And everything is great. No issues. So how are what attached, Farid? I'm not following here. There's just a delay between what you guys see and what you type, and then what I see from your typing, so that's why I'm reading stuff late. What makes sure that the links don't slip from each other? Basically that thing. So let's hide that. Let's hide that. There's a shaft here that we drew last time. Oh yeah, I didn't show that on stream. Sorry. Yeah. Basically, we added an extra shaft coming out of this, so that the bearings, the ball bearings, would go into them. So if we hide this as well, this ball bearing as well. Yeah, it goes into this shaft. And we can make this shaft longer or shorter or whatever we want. The ball bearing, it sits on it, so it doesn't go right or left. But after that, it gets hidden by that bracket. So just back everything. So yeah, we have ball bearing into the shaft and then closed off by this side. And the thing that makes the tibia doesn't move is this. They're all nuts and bolts that are going to be put. And this is the entire thing is attached. The servos are attached through spaces for their bolts. So everything is going to work out pretty great. And we're actually going to print one and test it. So for everyone not able to visualize what this is going to look like in the end, we are going to actually print this, 3D print it, and actually shoot it as well and make a video about it. So you're going to be able to see everything that we do here in real life after that. This is just drawing stuff to see what do we need to print in order for all of this to work. If you're new to using softwares like this is a very great way to learn it. Just try stuff, visualize it first, simulate everything, and it's basically like I'm telling you exactly what to click and what to, if you want to do something like that. Of course, you have your imagination that if you want to do something else. This is a graduation project, so it might be a lot if you're still learning these things, but basically same steps. You just extrude boss, extrude cut, you know, fit something here, sketch something there, attach something to something using the mate option. If you're able to get, let me my head here. Yep, that's the mate option that I keep using. Or if you don't have this thing, you can just right click on the thing that you want to mate and you'll see this mate here. Oh, you cannot see right click. Well, basically if you right click, it will also give you the option to mate. So there's that as well. Return my head back. So basically, two C's are going to be attached to each other through bolts. I didn't print that yet because I keep changing stuff about the C brackets, and every time, like if I make a circle here, if I decide to make a circle here, and then I adjust the dimensions of the C bracket, the circles are going to move, and they're not going to move aligned, like they're not going to be aligned to each other very well. So if it moves here, since these are both the same C bracket, so another circle is going to be created here, and I need to figure out where to put them in order to have them aligned in a perfect position. So this part's going to be the very end after we figure out everything else. But in real life, these are going to be holed, like there are going to be holes here with nuts and bolts. So, but this part can be kept to the very end, actually. All right, so what we need to do now is we need to go grab ourselves a trigger switch, limit switch. So let's go that. Guys, what I'm So if you want ready things like the servos, of course I didn't draw the servo myself, and if you watched my previous streams, you already know that I didn't draw all of this myself. A lot of things you can actually get ready made from people who draw these things and upload them on GrabCAD. So GrabCAD, how it's written. And basically, yep, okay. So this how GrabCAD is written. That's the website that I'm using, and you can actually see a lot of things already drawn here very nicely by people who draw this and put them for free. And if something is not for free, you can find it in any other source. Many people put things here. And also, the thing that we did offline is we removed, remember the Jetson Nano that had so many parts that it started glitching and making issues for us? We removed that and put a Raspberry Pi, so that's how we fixed that. I already said that in my previous stream that I'm gonna do that offline, and I did. So we now have a Raspberry Pi instead of the Jetson Nano. So let's look for a limit switch. Not working great. That is basically what we need. This one. Just gonna open a couple of them to see. One is not working, then the other will work, hopefully. Not really sure why music keeps running off. My internet should be good, so I'm not sure what's going on. My internet is not good if it's taking that long to open limit switch. Oh no. I'm not gonna be able to take that. It will say a different version or future version. That's what I hate about these things. About any software. That just be working with something and in the end it just tells you, oh, sorry, we're working with a different version of your software. So you're not able to download it and use it on your side. Same software, just different version. So nope, you cannot use it. Let's try that. There are a lot of limit switches here. God, the music just cutting off. It's annoying. Hey, this should work. Yeah, one should work. Let's check this out too. One is not gonna work. So, got our part. Not working properly. So give me a sec. Hey, we got it. Let's go. That's the thing we need. So basically what this does is, once this is going to be facing at the bottom, so first let me just add it here. God, this is getting very heavy to deal with. God. Come on. You can do this. Guys, this is how we made stuff. Okay, so this, stop moving, please. Thank you. I want this in down. Or actually, yeah. I'm gonna limit it with how do I want to make this? I made it with why is it not touching it? Something's wrong here. Right click yes. Of course it's gonna take a year to acknowledge. Like the made type. That's what I did. Cancel. Of course, what's going on? See what are the mates. Okay. Oh, is it made in the text itself? Good God, please tell me no. Let's delete that mate. What? Okay, this is gonna take a while. So if it's mating with the text itself, so let's mate this. Please move. Thank you. Feel like I'm betting the parts to work. And let's mate. This is a flat surface. It is. Made this. This. Why? Why won't you? Why? Tell me why. Ain't nothing. Hey. Why? Bruh. Maybe the problem is this actually. So, I let it do this. Let me just make this with this. Other mates will be broken and will be shown with error. What other mates are gonna be broken? Oh, I get it. God damn it. Yeah. Basically, let me explain what's going on here. Thanks for continuing this on, Freight. Basically what's happening is that I'm trying to make this face be parallel with this, which is working, no issues there. And this face is perpendicular to it, so this thing is perpendicular to it. So in order for this mate not to be broken, this face and this face, the one at the bottom, this one, need to be perpendicular to each other as well, which they're not. They're not perpendicular to each other. So that's why it's not understanding what's going on. So if this, see, these are not perpendicular to each other. That's why it's not doing what I wanted to do. So what we can do though is make this line instead of a face with, I'll tell you in a sec, it just needs to start freaking moving, please. With this. Now it's gonna move, see? Now it went right to it. And now we need to be... what? We need it to be parallel to it? Okay. But I need it to be the other way around. So undo that. this line. Is what? I need it to be this line. Yeah, but the other way around. Thank you. Good God, man. It's turning it into a chunk. Like you see, whenever I try to move, it turns this thing into a chunk, the limit switch. If it does that, that means it's very slow. It's not even registering stuff properly. And okay. I need this to be away from this by a distance of 5, let's say 5, 1 centimeter. Oh, let's make it what? Let's make it 3 centimeters. Yep. Thank you. Thanks. Okay. Oh god. What else do? Need that limit switch down a little. In real life, it would be put somewhere here, and then I'd need metal thing, or like the tip of the leg, have a metal rod just pushing back on it to let it know when it needs to stop. I already removed the Jetson Nano. There's no Jetson Nano here. What are you saying? There's no Jetson Nano here. The issue is the laptop itself. It's literally burning. Yes, I'm only working on the LED. It's burning. I have OBS on. I have my mobile recording and connected to all of this. I have Solidworks. I have my music in the background, which is Google Chrome and stuff like that. So I have a lot of stuff going on at the same time. It's a miracle that my laptop is working, and I know it. But, I mean, it's still annoying. Alright, so what else can we do? If we move this, is this gonna freak out? This. Yep, the trigger is freaking out. Need to mate it one more time. Okay. In order for us to mate it, we're gonna have to do something. Huh. What do I want to do? First, let's actually just finalize this. We're not gonna mate anything else regarding this, but let's do something. First, let's rebuild so it doesn't freak out on us. Okay. Let's go through this. Edit part. I'm gonna try something. Alright. Remember, where is it? Not that. Not that. Not that. Where the heck is it? that. Nope. That. Yep. Strut. So yeah, remember this strut? We're gonna edit it. And you'll see why we're gonna edit it. So as I said, we're trying to make something here to remove this tip and put like an attachable tip of our own. So let's do this. Trim. All right. So all of that, let's just do everything. Let's do this. Want it to start from here, something like that. Come on, buddy, got this. Okay. Huh? Okay. So let's give it dimensions and have it to be like, I don't know. From here, here. Oh, it's actually drawing, not given dimensions. Art dimensions, please, thank you. Here to here. Let's see. I'm gonna have it to be 2 centimeters, like that. Thank you. Working. Finally. What else? Want this? Okay. Let's out of that. Want this point be, we want to make this midpoint with this. Where is it? I'm gonna find you. This midpoint. Vertical together. Thank you. Okay. So we also want this thickness. Are you working? Not working. Our dimensions. Thank you. Please. We need this to be. What do we need it? So a rod is gonna come into this place. So let's say the rod's gonna be like 3 millimeters thickness. How long is it? Gotta get my ruler and see for myself. Let's have the rod be 5 millimeters in diameter. We're gonna do double that so it doesn't break. So let's do this to be 1 centimeter. Nice. Okay. Yeah, that sounds about right. What else? What else? What else? Huh. Have this as Yeah, let's have it to be 2 centimeters. This as well. God. If I had more subscribers, I'd start earning from YouTube and I'd get a better laptop. Alright, start building my PC, so subscribe, people! Help me! 2 centimeters. Okay. This should actually fit everything. How is this still not defined? Oh my god. Nope. Didn't we do this dimension? What happened to it? Yeah, that's why I keep saying this should be already done. Okay, so now that this is done, let's extrude and see what we did. Feature. Did nothing. Okay. Good God, man. This. Edit feature. Yep. Thank you. That's exactly what I wanted. Okay. In the middle here, we're gonna do sketch. This. Gonna do 5mm circle. Perfect. Let's have it with this. Okay. Then with this. Thanks. Right in the middle. And have it featured as extrude. Up to next. Great. Okay. That's where our rod will come in handy. Oh wow, what the heck? That's messed up. Huh. Okay, we can fix that. We can do the hole from this side instead. Yeah, probably should do that. Okay. Let's actually do that. But trying to draw in somehow. I don't know, man. Okay, we're gonna figure this out. Five millimeters. Okay, let's make this with this. Then this with up. Now where did that go? Okay, that's much better. So it's just not with this angle. That's the only difference. Great. Okay. Now we can just exit. Save. Everything's done. And let's rebuild. Alright, so far, everything's going great. Here's the thing about the tip. First of all, we can actually trying to figure out where this should meet, like the rod coming out of here should meet this part. This part. So we're gonna figure that out. Then we need that tip to be detachable. So we need something to get attached to this and be able to connect to it from here, a rod or something, or through a pin, something like that. So that's the next move. And limit switch needs to be in a house. So we're trying to put that limit switch inside something where it wouldn't move up or down or right or left. So we can actually attach its pins to something like that, take the readings and stuff like that. So let's try to figure out what we can do regarding this. I'm gonna take a few moments to think about this. So give me a moment. Okay, so stop moving. I have that rest on pins like I can extrude sides from there. From the extrude here, so it sit on it. As well as from the other side. So I can make basically a box for it where it just goes in. That box cannot have that part touch anything else. So we can do. I need to know where this. Yeah. Okay. Can I just open Twitch alone? See mentions. Yep, thank you. That's what I've been trying to do. You know what? I'm dumb as fuck. I didn't see these two holes. I can just put them through these holes, so I can do this. God damn my dumb brain. I can just extrude two little pins that go out and through this, so it doesn't go down, up, or right or left. And then I can extrude something from this part that's a flap or something. I can just stop this from moving, right, or I mean out and in. True, bolts and nuts would be better. Thinking of something else. It will just take me a lot of time to do. I don't want to do. I'm lazier than you guys think, so. Basically, here's what I'm thinking. This trigger needs to be on top of this hole. So it needs to come outside here to be in. It's basically, it's like in mid-air. It needs to be in mid-air here. So I can just extrude something from this side and this side and have this rest inside the box that I create here. So I can just create its own box over here. And that's it. That's basically it. I can create its own thing over here. The reason I don't want to do it, it's gonna take a long time to figure out like the dimensions of the box that I want and where the hole should be for this to fit for this trigger, this part that I'm marked on, be exactly on top of this. So that's my only issue right now. No, it wouldn't be a separate box. It would be part of the tibia. Like I would recreate the tibia from here, inside here. So let me show you what I want to do here. It's just a crude drawing. It's not the end effect or anything. So let me show you. Okay, I want to open this part. Actually, just edit part. I want everything else. Hidden. Thanks. Okay. So Here's what I want to do. I'll show you. I know you already got it, but I will still continue and show you. Come on. Say 31. Okay. We got this, chat. We got this. Oh, 0.0305. Okay. Gonna exit that into that. You'll know why I'm doing this now. I should be able to see the hole there. Yeah, should be able to see it. That means not being incorporated. Okay. Let's do this. Haha, gotcha. why are you giving me an error? You know what I'm trying to do, right? Okay. Oh, okay. Too far. Perfect. It is. Yeah. Now, onto that. I do here. Still gives an error. Um. Should fix it. Why are you still giving me an error? Are you freaking kidding me? Maybe it's barely touching here, but it's not though. Oh, thank you, Van. Thank you. And welcome to the stream, by the way. Even though it's a short time, but welcome. So, I'm just trying to figure something out, and it's not working out for me at all. So, it's gonna work out eventually. Finally. Good God, man. Okay. So, ah, here's what's gonna happen to the trigger. See, that's why I didn't want to do it. I told you it's gonna take a long time, and I'm a lazy person, and bruh, bruh. I had to. I'm sorry. Alright, where the heck is my limit switch? Let's just delete it, actually. It's not... it's inside there. Um, let's re-add it. Thank you. Okay, so we want this face be what do we want? We want this looking down, this that side made with that side. Yep. Then we want side made with but the other way around. Thank you. Here we go. Then want tangent this there we go. Now we can actually, after we finish this mate, we can actually go to this. Where is it? Yeah. Offset extrude. Edit that sketch. Not need to 100 meters. Be 20 meters. Yep. Huh. Still considers it 3. Think. Oh, it's because of the tangent. Yeah. Um. I just note it. instead of going all this way, just be 1 centimeter or something. Oy. Yeah, that's what I want. No errors. That's rare. Yep, there we go. This is how it should look like. This side, be able to see the trigger. Yep, that's the curved trigger. Once the shaft hits that, trigger this. This is gonna be inside of its little box, not being able to go up or down or right or left. And if you see this place as empty space, it's not, because the trigger, where the trigger is there. So this trigger is touching here, touching this wall. So it cannot go this way. So yeah. The only thing that we need to fix now is so it cannot go up or down. This can be fixed with bolts going through this. So easily fixable, very easily fixable. You can just pass a bolt from here to the other end or something. From this and this side, from the circles. It's very easily fixable. It's not going to be aesthetically pleasing, but it is fixable, so at least we got that. And just do this. Yep. Let's save. And now we have a leg, just missing the tip. So the tip is going to be something growing here. And then let's do new part. Now, how long do we... I actually have an idea for that tip, but it's gonna take me a very, very long time to do, so I'll rethink it and see what we can do. But for now, I've been streaming for almost 2 hours, 2 hours minus 5 minutes, so that's my time, because I actually go at this time. For now, we did a hell lot of progress actually. We covered these ball bearings. We were able to fix everything that was issued here. We extended that so we can cover these ball bearings as well. And that one, we recapped for everyone missing what's been happening, and we fixed our trigger. Like, we made a trigger, a limit switch here, and we put it in its place. We fixed the tibia. We opened the place for the shaft to pass through. If I'm free today, I'm gonna continue this tip and I'll update you guys later. But for now, that's actually all we need to do for now. For after that, the ledge is done. We just need to simulate to see if all of that's gonna work and be able to handle the pressure or everything that we put on it. Other than that, I believe this stream has been very productive actually. The next stream, not sure when, but I should probably not sure if I'm gonna do it in a stream or privately actually. As I said, I'll continue the tip anyways privately, because this will just take me some time to do. I'll update you guys regarding that, and if I'm able to simulate, I'll record it as well. Even if I'm working on my own time, I'll record it, because the simulation is very important. I need you guys to see it and learn how to do it. how to do your fixtures. So it's gonna be a whole lot of things to do. But for now, thank you for tuning in and see you next stream.